Hello and welcome to today's biology session. I hope you all are doing good. Today's topic is vaccination, how it causes immunization against pathogens. Looking at the slide, we have a few terms here: vaccine, vaccination, and pathogens, immunization. What are all these terms actually about? A vaccine is a substance that is injected in our body to protect us from a certain disease. Vaccination refers to the process of injecting the vaccine. Oh, it hurts actually. Immunization is the process by which a person stays protected from that disease. And pathogen refers to the nasty one, the one who causes all the disease and all this trouble. So, today's lecture is going to revolve around these terms, and we will try to understand how vaccines can be protective for us against some diseases. Let's go ahead. So, what are vaccines? Vaccines are the perfect defense against any disease that can be preventable. Before coming to the term vaccine, it is important to know about the term pathogen. As I told you, it is the nasty one. Yeah? A pathogen is defined as an organism that causes disease to its host. Okay, it could be any microorganism, it could be a fungus, it could be a virus, it could be bacteria, anything. Okay, so any organism that causes a disease to its host is called as a pathogen. And what is a vaccine? A vaccine is a preparation that improves immunity to a particular disease. It is a biologically prepared product which contains agents resembling a microorganism that causes diseases. A vaccine could contain an entire microorganism. It could be weak or it could be dead. Okay, we call the weakened organism as attenuated, or it could just be some portion of that microorganism that leads to an immune response. Okay, so there are so many vaccines which we have been talking about, or which are available for us. As babies, we all have been vaccinated. Examples include vaccines for measles, hepatitis, HIV, okay, and of course, the most talked about these days is that of the coronavirus, right? We all are getting vaccinated against it. So the mechanism is that a part of this coronavirus, or a toxin, which is a protein of the coronavirus, which is known as the spike protein, that is injected in us. Okay, so that injection is the vaccine. The process of injecting that vaccine in us is the vaccination. And once we are vaccinated, we become immune, means that immunization happens inside our body. Our body is prepared to fight actually against the actual coronavirus, if at all we encounter it. Now, how these vaccines work, before we talk about that, we will have to first learn about how the immune system actually works. Okay, because the basis of working of vaccines lies in the base of immune system working. For this, you will need to know about two terms. Number one is antigen, and the second one is an antibody. An antigen is any substance that causes your immune systems to produce antibodies against it. Or to make it simpler, I should say, an antigen is any substance that makes your body or provokes your body to fight against it. Okay, so any substance that causes your immune system to get provoked and fight against it, we call it as an antigen. Okay, so usually antigens are some things which are foreign particles. It could be any substance from the environment, such as chemicals, or it could be a microorganism or a pollen or any pathogen, as we just spoke about. A protein made by plasma cells to fight against this antigen is called the antibody. This is the second term that you will need to remember to understand the functioning of vaccines. Antibody is a protein molecule that is produced in our blood by our WBCs, or to be specific, what we call as plasma cells. These are a type of white blood cells in response to an antigen. So whenever there is an antigen inside our body, our plasma cells are directed to produce something called antibodies. You need to remember that each antibody is specific to an antigen. Okay, it is very specific to an antigen. So it just like enzymes, okay, as they are specific, similarly antigens are specific, antibodies are specific to antigens. Pathogenic viruses and bacteria, they have molecules on their surfaces. Okay, as I told you when I was talking about the coronavirus, it has a spike protein, and that is the antigen for it. Okay, this antigen stimulates the immune system to produce proteins called antibodies. And then what happens? The story begins. Yes, the fight begins. The antigens and the antibodies, they bind, and the antigen is killed and thrown out. Okay, so this happens by something called antigen antibody response. You can see here, this is an antibody. Okay, the Y-shaped molecule, it is produced by the white blood cells, or specifically what we call as the plasma cells. They bind to the antigen. You can see this, they bind to the antigen, and what they form is called an antigen antibody complex. Now these antibodies, they have two main roles. Number one is that they bind to the antigens, the specific antigens, to launch an immune response. Okay, so they just trigger the immune response, and what they do is they also activate other components of the immune system to fight these pathogens. There is a series of events that then happens, which includes inflammations, pain, fever. Okay, all these things happen, and many more, itching, etc. And that ultimately destroys the antigen. The second thing that happens once the antigen is thrown out, or once it is destroyed, these B lymphocytes that I was talking about, the B lymphocytes which produce the antibodies, their role is now to form memory cells. Okay, memory cells means the cells that are going to remember the same pathogen. Okay, they will remember this antigen, and what they do is they will remember the pathogen for faster antibody production in future infections. Now, if the same antigen comes in again, and it tries to bind to the antibody, the memory cells will take over, and the production of antibodies will be very fast, hence giving very less time to the pathogen to attack the body. So very quickly the entire army will come, and yes, they are going to kill this antigen very fast and very effectively. Okay, so this was about the antigen antibody complex. Now let's have a look at how antibodies are produced. The initial response of a lymphocyte when it encounters a pathogen for the first time, the antibodies which will be specific to this antigen, it takes a few days to be produced. Okay, but the lymphocytes, once, as I told you, once the infection is over, these lymphocytes will keep a memory now, right? So they will keep a memory of these antigens now, and in case of reinfection by the same pathogen, antibodies will very quickly be made in greater quantities, and the pathogens will be destroyed before they can multiply and cause any disease. This is how the immune system can become, this is how we become immune to certain diseases only having them once. Vaccines safely expose the body to pathogens so that the immune system can make antibodies capable of binding to their antigens. This allows the immune system to fight off a specific disease-causing pathogen should it encounter the pathogen in future. Okay, so that was all about how the body fights against the pathogens and how the vaccine actually works. Now let's recap with these two images. See, you can just check this image. This slide shows how the individual is being injected with a harmless pathogen. So this process is vaccination. The injection that you see, that is a vaccine. This process is vaccination. It contains the antigen. Again, I will repeat, the antigen could be a dead or attenuated, means weakened pathogen itself, the entire microorganism, or it could just be a part of it. Now, when the immunization happens, the antigens, they trigger an immune response. It can take days for a lymphocyte making complementary antibodies to be activated. Okay, so this is the first response, and it might take a few days for the body to produce antibodies against this antigen. Lymphocytes produce complementary antibodies for the antigens. The antibodies, then what they do is that they target the antigen and attach themselves to it in order to create memory cells. Okay, so here you see the memory cells can be created, they are generated, and these memory cells, they will remain in blood. And what they will do is they will quickly respond to the antigen if it is encountered again in an infection by a live pathogen. Now, in case a person faces the actual infection, the body is already prepared with the memory cells in the blood. As memory cells have been already produced, this immunity is long lasting. And therefore, we say that vaccinations provide immunization against certain diseases. We need to remember that vaccinations are a safe method of protecting an individual against certain diseases. These are dead or altered form of a disease which contains the specific antigens, and these are introduced in a weakened form. Okay, so they cannot cause illness, but they can only provoke the immune system, all for its good. That's all from my side. Thank you so much. Have a nice day.